My name is Laura Thorson. I'm a program manager at GitHub on the DevRel team. I'm excited to welcome Nick and Naroshan tonight. God, I'm having a hard time. What day is it? What time is it? I don't even know. We're excited to have them. This is going to be a really fun session, so please hurry, come on in, find a seat as fast as you can, because we're about to get started. Join me in welcoming them, and we'll put up a round of applause. Here you go.
Firstly, a massive thank you for everyone choosing to come to this talk. There were some great talks going on at the same time, and I do realize it's also lunch. So I really appreciate you making the time. So I think it's worth addressing the elephant in the room. Yes, me and Nero are attempting to channel our inner Terminator. And yes, we are trying to also channel our inner AI. But again, this is not a normal Wednesday look for me, just to be really transparent. I don't rock around San Francisco every Wednesday looking like this. Nero, on the other hand, no one really knows. This was Nero's idea all along, and he's been so excited. So this may be a Monday, Tuesday, Wednesday look for Nero. So why are we dressed looking like this? So I think like a key theme a lot of you have heard over the last half a day, and you will continue to hear over the next day and a half, is how GitHub is infusing AI into our platform. And today, over the next 40 minutes, you are going to get a demo around how we are doing that within GitHub Advanced Security. So we wanted to start as we mean to go on. This is going to be a very informal, a very relaxed session. It will be very interactive as well. So again, we wanted just to open up as we mean to go on. So with that, I think before me and Nero do any introductions, and as people still pour into the room, we wanted to get to know you a little bit more. As I said, we are going to be spending the next 40 minutes together, and it's not just me and Nero who you want to meet. We want to meet a little bit about you. So it's been very simple, very easy questions. So can I get a hand up if you are a developer or you work with DevOps, if you're sort of writing code? Okay. Can I get a hand up if you are in security or you're in some sort of AppSec program? Oh, okay. I have noticed a few hands have not been raised. So maybe like a hand up if you haven't fallen into any of these categories. You're possibly at the wrong conference at the wrong talk, but heard about two Terminators. Yes, yes, I can see a hand. Yes, absolutely. That is exactly why you are here. Okay, so we've got to know you a little bit more. But I think I want to open up with just a final question. And yes, I am that guy, by the way. So what I would like everyone to do is actually stand up. Yes, I'm that guy, I know. So can everyone please get off their seats? This is the only time you're going to have to move, I promise you. There is no more movement. Okay, so I want everyone to stay standing if you or your developers in your organization come to work every day and say, I love remediating vulnerabilities, and I love my security tooling. So stay standing if your developers love security. I can see a few GitHub people standing, and I love that you're still standing. But yes, I think there was a few people that still remain standing. So I think why I asked that question will hopefully come back, and we will link back to this throughout the presentation. So with that, we've got to know you a little bit more. I think it's about time that you got to know me and Nero a little bit more too. So hi, my name is Nick, and I am a developer. Well, I'm a developer whenever my job really allows me nowadays. But my background is software development. I've done technical leadership, and I'm now in the job I love the most, helping lead and spearhead what I believe is the world's best application security tool, GitHub Advanced Security. Outside of work, for people that know me, you will find me on the golf course. I'm an avid golfer, and I also watch Arsenal. Do we have any Arsenal fans in the audience? Oh my goodness me, you get t-shirts. Boom, there's one, and who else? There was a second. No, no, you don't get one. Oh, you're an Arsenal fan, yes. Okay, that's the second one. Beautiful, that's a great start, by the way. I did not expect that in the slightest. So that is me. Nero actually hasn't moved for the last, I think, since we started. So Nero, are you ready to introduce yourself?
Hi, I'm Nero. And if you haven't gathered, I'm a huge sci-fi nut. So I'm really excited to bring this experience to all of you today. I've been a builder for 30 years. Much like many of you here today, I was a developer back in those early days. I know my profile picture maybe looks like I've been doing it a lot longer than 30 years, but time has been kind to me. I've been building software from avionics systems to software that goes in mobile phones. And one of the things that really struck me in my career as I was building the software was how important having a good developer ecosystem was to enabling us to ship software on time. So as part of that journey, I'm really excited to be here at GitHub to be able to influence how the world does that today. So with that, I'd like to hand over to Nick, and why don't you tell us what we've got planned for the presentation?
Yeah, so I think like all fun aside, you are here to hopefully learn and hopefully get some perspective. So what are we going to be covering today? So before we dive into any sort of future, any of the fun topics, I think it's always important to level set and talk about some of the challenges that we've seen in the security industry over the last 20 or so years. One was already really identified with that stand down, sit down question. A lot more of you should be standing, but a lot of you sat down. So we'll be talking about some of the challenges, but what does challenges present? Opportunities. We'll discuss some of these opportunities and specifically how AI has allowed us to think a little bit differently about how we couldn't maybe solve some of the challenges that we had before. We're then going to move on to what I think is the funnest part of this section. You're actually going to see some of these things in real life. You'll see some internal tooling, and you're going to see some of the ways that we're thinking about delivering value in a very different way. And then we're going to end with some Q&A. And with that, Nero loves really hard questions, by the way. So please, throughout this presentation, if you ever think of any hard questions, save them. Nero will love to answer them. So with that, that is what we're going to cover. Nero, I'll pass over to you to get us kicked off.
Thank you, Nick. I can't tell you all the Arsenal fans how much you made Nick's day, because when we rehearsed this, there were no Arsenal fans in the room. Oh, excellent. So as we think about what's coming in front of us, this statistic here is something that really strikes home to me. So if we look at this here, what it's saying is that over the next 5 years, there are going to be over 700 million new applications that are built. And this is more than what we built as a planet in the last 40 years. So this is really a lot of work that we need to do. But what's even more interesting is, like, I've been presenting this slide now for a few years. And very recently, this number jumped from 500 million to 700 million. And when we think about all the generative AI work that's happening right now and all the new use cases AI is letting us, take advantage of, I can see this number jumping to 1 billion by the time we come and get together next at next universe. So as part of this challenge of building software, though, security is actually getting a lot harder, right? And a really good example of this is Log4j. Quick hands up here, whose company was impacted by Log4j? Cool, okay, good proportion. Keep your hand up if it was a good time for your company. No, okay, there we go, we got 2 t-shirts, so there you go, take one.
We have 45 of these t-shirts to go on, by the way. So get
and I'm not
ready
taking it back to England. Next question. We're giving early responders t-shirts too. So what's really interesting with Log4j, so back in 2021, it was quite a stressful time for all of us that went through that. But what's really insane is if you look at the statistics around what happened as nefarious actors tried to act on that vulnerability, we saw 2 times the number of attacks in the first 10 days of Log4j compared to what happened in a whole year after Apache Struts. And we all now know how infamous Apache Struts was. So it really tells us that we have this great opportunity to build all these exciting applications, but with this great work comes great risk. And that's really what we're thinking about here at GitHub, is how do we empower customers to be able to do better here. And so as we think about what this process of application security looks like today, I would say that this is an old slide, but actually 80% of customers today actually have an experience that looks like this. This is essentially talking about how we do DevSecOps today, right? So you have your developers, they write their software, they want to push that software into production, and today the security teams are responsible for running those security tools, reviewing the results, and then pushing the interesting ones back to the developers. If you're a security persona, not only do you want to know about the critical issues that need to be fixed, but you have a low tolerance for risk, so you want to understand like some of the risks that might be in the application and make decisions on what you want to do there. And that's great because you have the time to review it and push it back. But the challenge, of course, is that when we're running security very late in the process and then trying to give the feedback to the developers, what we see actually is that that's very expensive, right? So if we look at the cost of fixing a vulnerability when we're in test or production, it's 10 to 100 times more expensive than fixing that issue at the developer's desk. So there's a really simple idea. Well, let's shift security left. Let's put security where the developers are today. But there's a big challenge in that process. And actually, quick show of hands here, who has tried to integrate security into the DevSecOps process today? I'm going to ask the question again. Hands up if it was a good experience. You're honest this time. You should get a t-shirt for being honest. I'm going to do an honest t-shirt. There we go. I'm going to try and make it to the back. Oh, I'll do one more. It was also for the gentleman behind you. That's okay. Oops. Excellent. Right, so what we learned is that integration doesn't equal function. So taking a security tool that is built for a security engineer who has time to review results, wants to know all this information, and putting that in a developer workflow is actually quite challenging. And a really good analogy of that is think about what DevOps looked like before. So if you go back 20 years ago, you're writing a software, you would run your CI/CD, you'd run your validation build, you'd run your test cases and confirm that everything worked. And when things would get bad is when build processes or tests became flaky and developers stopped trusting them. The signal to noise ratio meant that they couldn't trust what was coming out of it, and that started the journey of erosion in that project. And it's a very similar thing with security. If I'm a developer, right, which I was a while ago, and you all are, there's a lot of pressure to get code out, get product out. But if I now put this process in my way where it's saying, here are 100 issues that you should think about, but actually 2 of them are actionable, well, what am I going to do? The first time I'll do it, the second time I'll try, and the third time I'll be like, hey, do you want me to ship the code or do you want me to deal with this? And that's exactly what we see happening in AppSec, is that taking a tool that is optimized for a security persona's mindset and trying to embed that retrospectively into developer workflow, it doesn't work, right? And so really, we need to think about how to work better through this. And actually, a really interesting analysis that we've done at GitHub is thinking about like what is the benefit of improving the developer experience, right? We all understand this today. When you have a encouraging or a positive developer ecosystem, it's very easy to make changes, it's very easy to innovate, it's very easy to move things forwards. But as soon as you start to introduce friction to that process, then things start to slow down. And actually, it turns out that when you provide your developers a healthy ecosystem to be able to collaborate and contribute software, well, that starts to drive up developer velocity. When you drive up developer velocity, your business is able to innovate faster. And the McKinsey data here tells us that actually when you have good developer velocity and a good developer ecosystem, well, it turns out it impacts your bottom line. You make more money because you're able to innovate, capture market share. In fact, you're 4 to 5 times more doing better growth with your revenue when you have a good developer ecosystem compared to your counterparts. So really, there's something very important here about thinking about how we want to improve the security experience for developers. And so as we go in here, so GitHub, obviously GitHub Advanced Security, where Nick and I are from, is a product that has taken application security and embedded in the tool. But what's really important to understand is the journey of how we came to this point. So 4.5 years ago, GitHub acquired a company called Dependabot and a company called Semel, which is where we built CodeQL. And we had a really interesting choice to make at that point in time. Did we want to provide these tools that were quite competitive in the market, right, used by security individuals, and have an integration into GitHub, but have them as standalone security tools? Or did we want to try and do something different that addressed the points that we raised before? And so we actually took the core engines out of these tools and then embedded them deeply inside GitHub, right? Because what do we know today? GitHub is a place where 100 million developers are collaborating. They love the workflows, they love the process, what they do in the open source community, they take into the enterprises and they bring that innovation. And so what we said was, well, how are developers collaborating today? Well, the pull request, that's how they push to production. So let's try and get relevant information to them in the pull request so they can make a better decision. They can add quality gates to that process. And it was the same thing for secrets. Like, once the secret is in your repository, it's game over. Now you have an incident response scenario. You have to go through the cost of triaging what's going on and what the exposure was. So let's prevent people from doing that. So let's integrate directly into the push process, but not by getting people to install tools on their PC, but making it part of the core experience. And so these kind of principles have meant that we brought security to where the developer is, instead of trying to build some kind of hokey integration to try and get to that point and then trying to manage that at scale. And so it turns out that being where the developer is has a really high impact on remediation rates. So if we look at this data here, you can see that, I think it was the Veracode State of Software Security report, they said that in a typical enterprise, after 7 days of a vulnerability being identified, only 15% of those vulnerabilities are remediated. But I have a quick question for you. How long do you think it takes for us to remediate 50% of the vulnerabilities? So let's have a show of hands. If you think it takes 2 weeks, put your hands up. Okay, 4 weeks? Okay, some optimists in the room, I like it. 2 months? Okay, 3 months? 4? 5? Well, SLAs can always be negotiated if you have like a ship requirement. 6 months. Okay, cool. Everyone with 6 months, keep your hands up. So you're right, it actually takes about 198 days, so between 6 and 7 months to be able to do that. And so clearly here, like this takes a long time, but what we identified with advanced security is customers that are using code scanning are able to achieve 50% remediation rates in real time, directly in the pull request. So how long does a pull request typically take? A couple of days to maybe a couple of hours? So good grab. So it's really, really impactful what we're seeing here. And so we have this 7 times improvement by integrating security into the developer process. I think we need to work in your throat.
Yeah, I must admit, I can't, like, American football would not be for me.
Right, but it is a t-shirt, you realize that.
Yeah.
Okay, so let's go a little bit further here. So AI, so hot right now. So if anyone's watched Zoolander, that's a Zoolander quote. So I love Zoolander too, so sci-fi and comedies. So AI is obviously very, very interesting. We're all trying to understand how to bring this into our developer processes today to help improve the rate at which we can build software. And when we think about this, actually, there's a really good quote that here at GitHub we kind of like follow as a principle. So this is Avi, and Avi is part of the board of OWASP, which is one of the committees that has a super interesting standard. Hopefully all of you have heard of it. If not, you should go and Google it up. Or Bing it up, I guess I'm supposed to say.
That was a terrible joke.
So, but what Avi says is that security at the expense of usability comes at the expense of security, right? And fundamentally what he's saying here is that if you're trying to integrate a security experience, but you don't do it properly, no one's going to follow it, right? And that's what all the data that we spoke about before is talking about. Trying to dump a security tool into a workflow of not optimizing for the experience will not get you the engagement that you want, which means it won't get you the remediations that you want, which won't get the desired result of removing the risk from your software. And so when we started thinking about AI here at GitHub, as Thomas said in the keynote today, this is not something that like the rest of the planet, ChatGPT, got announced in December last year, and we all got excited and said, wow, look at all the amazing things. This is something we've been working back from 2020. And incidentally, for those of you that you don't know, one of the founders of Copilot within GitHub was Ugo Demore, and he was also the founder of SEML, CodeQL. So it's actually very interesting, the relationship there of looking at this problem. And so when we went through this exercise, we thought about, like, we had lots of early fix scenarios where we were fixing source code. But we kept saying, like, this is not scalable. Like, if we deployed this and we only fixed 15% of vulnerabilities, we're going to have the same problem as like putting alerts in front of developers where there's a high signal to noise ratio. They'll engage the first few times, but now we're adding more work because they have to go and review these changes which are not correct. So we worked really, really hard to create an experience where the remediation rates are really high, and they're high for like non-trivial examples as well. And so that brings us to the 3 core use cases that we've identified as day 1 of taking a look at. And I want to say day 1 because this is not like we're done. We're at the start of a journey here. We're all learning together. The feedback that you all provide to us as you use these experiences is going to be really critical in helping us, understand and evolve and get better engagement. But when we look at the 3 use cases, the first one is detection, right? And when we talk about detection, it's that constant battle that we have between false positives, so results that are not real, and false negatives, which are like real results that exist in your code, but the analysis tool has missed it, and maybe that's because of desensitization that we've done to like reduce the false positive rates. And so it's super important that we can continue to improve our detection rates without introducing noise into the process. Remediation, we spoke about remediation just before. We have this good success rate right now, but we can always be better, and how can we continue to improve that? And then scale. It's about taking the principles that we're applying to the developer and then trying to talk to organizations and helping organizations actually scale that out. Because every one of you works in an organization where I'm sure there are security issues sitting there today, and we call this security debt. How can we help you pay down your security debt and then also address things like incident response and just knowledge sharing and things like that? So with that, Nick, you're going to jump in.
Nero, are you ready for some fun? I think this is where the fun begins. I will take
there we
that.
go.
Do you want to start framing up what we think about detection? Like, tease it out for me.
Excellent. All right, so let's talk about detection. So there are 2 parts in detection that we want to touch on. So the first part that we want to talk about is actually understanding what's happening in the static analysis process. So when you take a static analysis tool or a SAS tool and you scan your source code, not only does it scan your source code, but it needs to understand what's happening when you call through to these packages, these third-party packages that you're using. Another fun question, t-shirt opportunity. Hands up for those of you what percentage of open source software is used in a typical enterprise application today? Oh, we'll do numbers, that's easier. So 10%. 20%.
I think we can skip these 10% up.
Okay,
a little bit more
all right,
now.
50%. 50%, okay, 70%? 80%? 90%. There we go. Okay, I don't have enough t-shirts. So who was the first responder, Nick?
I wasn't looking.
Oh, that's terrible. All right. Well, we'll find another one then. Okay. So 90%. So 90% of a typical enterprise applications code comes from third-party software. So this means that you need to understand what's happening here. But when you look at what's out there, there's over 100 million open source packages that you can use to build your software, right? Some of these are really popular. So in a typical static analysis tool, they probably provide support for the top 2,000 and 3,000 packages. But there are going to be these bleeding edge packages. Generative AI is so hot right now. If you watch YouTube every morning, there's like a new video of like how someone has worked out how to do something with the GPT models. You want to use that? Well, guess what? It's not modeled. You can use it, but don't know what's happening inside there, right? All the way to, like we heard about Thomas talking about, organizations that have the code base that's running a banking infrastructure, COBOL code from the 1960s that are using packages that, well, not really interesting for a vendor to model, but it's critical to how like the world runs today. And so today, you have 2 processes. One is the vendor has to go and add modeling information for those packages, or you have to take like the underlying scripting language that those static analysis tools have, and you have to become a semantic analysis expert to go and build out that modeling information. And so we've thought long and hard about how can we partner with the community to empower all of you to help solve the scale problem. And so with that, let me hand over to Nick.
Yeah.
You can talk us through the first demo.
So like hypothetically, of course, could you imagine if we could automatically model every framework and library sitting on GitHub today? GitHub is the home of open source. And Nero alluded to the fact that 90% of your software is predominantly how you use open source. So modeling that is so important. What I want to show you is a real-life example of how this actually works. So let's go ahead and get this kicked off. Firstly, does anyone want to shout out what they think this file is doing at a really macro level? Does anyone want to be brave? Tell me more. Okay, on a high level, it is Java, that is correct. What you're doing is you are building in the video, we're going to go ahead, we import our Java libraries, we go ahead and we form a query, and think of this as like you are querying a database with SQL. So on a high level, you would expect to find a SQL injection here, because you're not sanitizing the data. This is our CoQL query that will go ahead and actually find the vulnerabilities. We ran it, oh man, no results. And I wonder why we haven't found any results here. I would expect to find it. Let's go ahead and click Start Modeling. So at a click of a button, we click Start Modeling. And as you can see here, we found the packages. And as you can see, it's unmodeled. So we don't really know how this package works. And I can view and understand within the IDE and see, okay, this is actually the data flow, this is the create query. So I can actually see, okay, we didn't find the vulnerability because I don't understand how it works. So you can see it's unmodeled here. Now, what we could do is just model with AI for this library, but we can do better. Can you imagine if we can model this for every repo using it on GitHub? So we go to the repo where this is actually found, and we go ahead and load out all of the methods that we actually see. So this is the actual library, and these are all of the functions. And as you can see, we have the package here, and if you scroll down, we're actually going to hover over the create query. So what we would have to do is manually go through and specify which is a source, which is a sink. We have to manually do this. Look how much is there. But I click a button, and we now model with AI. And our LLMs is going out and automatically understanding how this library works. And as you can see, we now have sinks. We now have sources. Leveraging AI, we have automatically modeled what this looks like at scale. So one click of a button, we have figured out the context. So let's go ahead and save this. If the video scrolls up and click Save All, let's save this model, and let's go ahead and rerun that CoQL query. And let's see if we're actually able to find that vulnerability. And as you can see on the right-hand side, because we've modeled it out, we've now found this vulnerability. So I think you've heard a lot on the keynote around auto-fixing. You even heard generic secrets. This is what people would think of the less sexy, but this is how we get to a large proportion of eradicating these false negatives. If we can say to you, we can actually no longer be able to provide you and miss some of these vulnerabilities because we don't understand how it works. There's huge potential here. So I think that this is very exciting, and you can see this on one package. But because GitHub is the home of open source, imagine the scale opportunities we have to run this across all of GitHub. So this is on a high level how the CoQL piece works. But I also want to dive into a demo and think about secret scanning. I think secret scanning is top of mind for a lot of people. And as you saw in the keynote today, we released generic secrets. So what does that look like? So I'm a developer, and I've been asked to come in here, and my task 1 is to build a reusable Postgres database. I'm like, OK, cool, pretty simple. I can do that. Now, versus me actually write code for you, which would be very embarrassing for me right now, I've gone ahead and pre-created a pull request with what that looks like. So as you can see here, I come in here, I go to the files changed. Let me go ahead and view that file. Does anyone want to shout out what line they think the secret's on? 10. 4. So Nick is being a mischievous developer right now. Nick is trying to trick our secret scanning system. Because in theory, a secret scanning tool may think that this line here is the secret, but in theory, it's not the secret. The actual secret is on line 4. But I've tried to trick the system and be like, hey, you probably think that line 10, because there's password there, you think that's the password. The actual password is being referenced on line 4. And that's why our secret scanning service that we released as of today will go in and will actually correctly identify the secrets that we found. So as you can see, I load this one here. and it has actually found it on the right line. We haven't gone ahead and we haven't found it on the connection string. We've actually found it where the secret actually is formed. So even if a developer was to try and be mischievous, like I have been, our secret scanning and generic secret service is actually able to find it at the right source.
Nick is mischievous all of the time. It's not just for the demonstration.
I'm never mischievous. So I think, let's move on to remediation. So Nero mentioned remediation is key. And a lot of you in the keynote probably heard our autofix and was like, yeah, we've heard a lot about industry looking at autofix. And do you really autofix? When you say you autofix, are you just autofixing very simple SQL injections? So again, what I wanted to show you is some real-life examples. So as you can see here, I have introduced a very, very basic server. So if I view this file, you can see I've introduced a server. Very basic. Now, if I go back to my pull request, as you can see here, I am actually, for example, in this one, I have a missing rate limiter. What that means, I actually have to install a new package, reference that package, and then actually install it within Express. So as you can see, I'm actually going in here and installing Express automatically. This is not just adding and fixing a SQL injection at its source. Our model is able to come in, see that we need to add a new package, go ahead, reference that specifically within our code, and then make that work. So we have an example rate limit here. We have a cross-site scripting fix here. If I scroll down, we have a server-side URL render in here. So again, when we say we support auto-fixing, we are right now going live with our default suite, supporting over 90% of the queries that we have. I think that is an incredibly exciting statistic. I think and that's why the launch for me is specifically is so exciting. So you can see this here, but I want to go a step further. And this is where I think Nero, this is what gets Nero the most excited about. Imagine if we could eradicate types of vulnerabilities. Imagine if we had the opportunity to be able to eradicate at scale various different vulnerabilities. So what I want to show you is a new way of thinking. And the way that I like to think about this is the get clean, stay clean motion. The pull request motion really focuses on staying clean, and you saw that in this example here. But could we go a step further and let's say eradicate all your current SQL injections across your entire organization? Well, let's go ahead and show you an example video here. So this is Juice Shop, for the people that know. It's an intentionally vulnerable application. It's used by a lot of companies. This is our code scanning tab, where you can see hundreds of alerts. So what we're going to go ahead and actually do now is go ahead and filter and find all of the alerts that are SQL injections. So we're going to go ahead here and filter by SQL injections. And this is showing you all the SQL injections that we found. So, okay, we want to remediate all of these vulnerabilities at a click of a button. Let's eradicate all of these SQL injections. What we're going to go ahead and do is head to our tool, and as you can see, the repo at the top there is the example that we're using, the one that is highlighted, and we're going to go ahead and do what we've done before. We find all the open SQL injections, and this pulls in our internal tooling all of these SQL injections. So with this, what we're going to go ahead and do is create a new data set, and this tells our internal service tool what do we want to remediate. So again, we're calling this universe demo, and these are the vulnerabilities that we want to automatically fix at a click of a button. So as you can see here, we've gone ahead and we've kicked things off. So we're going to go ahead and load and find the data set that we just created. So you can see the information here. So as you can see, the query object, this is all of our SQL injections. And step one is going to be to go ahead and clone the repo. So we're going to go ahead and run our command to go ahead and get this cloned down. So step one internally is we've locked the data set. Let's go ahead and clone down this repo internally, and this will go ahead and run. It will take a few seconds. As you can see, it's now running, and a few of them have stopped. We're now going to go ahead, and that is that done. For effect, we have sped it up just a little bit. So as you can see here, this is where all of our SQL injections were. I now go back. At a click of a button, we've automatically raised pull requests to fix all of them SQL injections that you found. So again, if you have thousands of SQL injections or thousands of Log4j vulnerabilities across your org, Can you imagine being able to eradicate these at a click of a button? And again, a big principle of GitHub is learning. So we don't just fix it, we tell you the types, we tell you how we have gone ahead and approached the fix. And as you can see here, we've linked to the vulnerability that we have fixed. So this provides the foundation to be able to be like, okay, we can automatically fix and eradicate these types of SQL injections. So we're happy with it. We're going to go ahead here, and again, we're going to speed through a little bit of our internal tooling. So as this continues to run, and then you'll see this speed up in a second when we go ahead and validate the fix. So as you can see, we also make sure that all the checks are passing. So as you can see here, we have green ticks next to it. So all of the actual checks have gone ahead and taken place. So we make sure that CoQL has actually gone ahead and actually like fixed that vulnerability. So as you can see here, we're going we're going in and we're showing you how we're fixing it, and we're going to speed through the actual merging of these fixes. Now we're not going to like go through one by one. As you can see, we're rapidly going through and getting these merged. And the question that I hope you're all thinking is, okay, sure, you've proposed a fix. That's great. Like, did it actually work? Did it actually fix? Did it actually eradicate these vulnerabilities? Let's go back to the code scanning tab. Let's go ahead and filter by SQL injections. There is none. At a click of a button, we've gone ahead. And yes, you can see quite a few processes there. But this is the potential that we have. GitHub is in this place where we actually are able to come in now and say, okay, how many SQL injections do you have in your organization? Let's begin that journey in actually starting to remediate them. And we can say to you, for types of vulnerabilities, let's start that journey to know more. So I think like as we progress on and as we sort of start to wrap up now, I think it's important to, if the slides move on, it's important to reflect and recap. Like, we opened up with a little bit of the challenges that we saw, and we opened up with a little bit around how we are approaching it. We showed you a little bit around how this is working. What I am most excited about, personally, if you were to ask me to reflect on, is the auto-modeling. I think that has such huge potential. I think like we are at such an interesting point within GitHub, being the home of open source, where these libraries live, that we have a big chance to make a difference. Nero, what about yourself? What one stands out most for you?
I'm super excited. I mean, autofix is something very near and dear to me. So I think it's a huge opportunity for us to like continue to focus on the remediation problem, and then scaling that to this ability to go and eradicate entire classes of vulnerabilities. That reminds me of like the whole work to eradicate malaria as well. There's a really unique opportunity here. So I'm super excited, and as I said before, like this is the start of the journey here, and we really look forward to learning from all of you on what's working, what's not working, and continue to innovate here. So,
Perfect.
you, Nick.
So I think with that, if you're interested, I saw a few of you taking photos. I think we are really open to starting to build up interest. So if it's something that you're interested in and want a conversation about, I hope you have hundreds of questions about how this actually works. And this is something that we are more than willing to have with all of you. GitHub tries to pride itself on being transparent. So if you're interested, like you saw on the previous slide, some are in private beta, some are in public beta, some of them are services driven right now. If you're willing to have a conversation and want to learn more, we're more than happy to have that conversation. So please feel free to sign up for the wait list. And with that,
Go back so you can keep the.
okay, yeah. Perfect. So with that, we have 1 minute and 42 seconds before we get really glared at for asking to leave. So I want to open it up to say, were there any questions? And does people want to probe any questions my way or Nero's way? Yes.
Oh, hold on.
Oh, hi. So was CodeKL trained on that repo that you showed?
What
Was CodeKL trained?
No. So no, CoQL, we do not specifically go ahead and like model and train it for Juice Shop. Like that's one thing that GitHub right now we don't do. Like you have synthetic apps. We won't go ahead and specifically model out Juice Shop or like any other intentionally vulnerable.
So you would say that the repo that you showed is out of the training set
Yes.
for that?
Yes.
CodeKL? Okay, that's cool. Also, I learned that secret scanning is autofix is only for JavaScript.
So
You know,
as
all the examples you showed for the
yes,
other parts is the get analysis tool that I forgot already, but it was also JavaScript. So is this everything just tied to JavaScript?
Great question.
Yeah.
So again, like I think one thing GitHub wants to do is partner with our customers and go on this journey together. I think like right now we want to start and make sure that we're successful with TypeScript and JavaScript. So yes, our autofix capabilities right now are for JavaScript and TypeScript, and I would stay tuned for hopefully not too distant future around 2 more languages that we're looking to release.
Thank you.
You can have a T-shirt for being the first question. Oops, sorry.
Hi. So my question is it possible to customize the autofix so that it works on some part of the code, but it skips others? For example, like if I have a series of SQL queries which works on only like system-generated data, so it's all like trigger-based sequence numbers and all of that. So ignore all the SQL injection warnings on those.
So right now, no. So right now we are targeting like it's just like we will look for all SQL injections and like we do it by rule. So right now, no. I think like to the question that was just raised, like right now we are looking for partnership with the right customers to make sure again like we want to validate and make sure that this works for our largest customers at the largest scale. So I think like right now we want to make sure this works for like all and for JavaScript and TypeScript. And with that, I know there are loads more questions. Me and Nero will hang around outside. I'm getting looks from the back of the room. So we are going to have to wrap this up. I want to say a massive thank you, though, for
Thank you all
coming
so
and
much.
attending this session.